For more information, please visit SGMAK Associates website.
In this module, I'm presenting different analysis methods to find the suitability of an alternatives and also select the best. So the first example is you're given 4 alternatives. Compare and find the best of the following 4 alternatives, and we'll compare multiple methods. So we got alternative A, B, C, and D. For each one, initial cost, uniform annual benefit, and useful lives are given. Useful life is the same for each alternative. Desired rate of return is 10%. So let's look at payback period first. One that is used often, is not based on sound principles because you ignore the time value of money. Nevertheless, it gives you a quick way to compare alternatives. So payback period is simply find out how long it took to recover the initial cost without considering time value of money. So payback period of A is you simply find the initial cost of $75 divided by the annual benefit of $18.8, and that gives you close to 4 years. In 4 years, you recover the initial cost. That's the definition of payback period, ignoring the time value of money. Payback period for B is initial cost 50 divided by annual benefit of 13.9. So that gives you 3.6 years. For C, following the same logic, is 3.3 years. And for D is 3.78 years. So simple logic says that quicker you can recover the initial cost, the better off you are. So you'll select the one with the lowest payback period. So you'll prefer C in this case. Alternative with the lowest payback period. Now let's look at another approach, the benefit cost ratio analysis. So all that you do in this approach, you find the present value of all benefits and divide that by present value of all cost. And if it's greater than 1, project is good, simply because if your net present value of cost is benefit is greater than net present value of cost, then your net present value of the project overall is positive. So it's preferred. So let's look at that approach. Benefit cost ratio for A is present worth of benefits divided by present worth of cost, comes out to be 0.95. If the ratio is less than 1, the project is not good. We will not consider it for further analysis. So A drops out. Benefit cost ratio of B is 1.05, and for C is 1.137, and benefit cost ratio for D is 1.002. Again, we find the present value of all the benefits divided by the present value of all cost. We look at the ratio greater than 1, project is good. So by looking at 4 ratios, we reject A because it has the ratios less than 1. So you got 3 candidates for further analysis. Future value of D is 0.3. So again, if you look at those values now, again B is preferred since it has the highest future worth as the desired minimum attractive rate of return, MARR. Since all the alternatives have equal useful lives, NPV analysis will lead to the same result as I stated before. Let's look at another example. Now I've got three mutually exclusive alternatives. You got to select one of them, and you got to find out which one is the best. You got the initial cost, benefit changes year one. You have one kind of benefit, and then benefit changes starting from year two. And the useful life, they're not equal. Alternative A has 6 years, B has 5 years, and C has 4 years. So let's look at the payback period first. Alternative A has a payback period. We simply add the benefit until we recover the cost. So it has a payback period of 4 years. Payback period of B is 2.6. We prorate the third year benefit. Payback period for C is 2 years. So again, as you stated before, payback period ignores the time value, and it simply computes the time taken to recover the initial cost, and it prefers that alternative that has the lowest payback period. So in this case, we prefer C. Moving on, if we just compute the benefit cost ratio, for A, we get all the present value of benefits and get all the present value of cost. But in this case, what you're doing, since they have unequal life, we're comparing based on equivalent uniform annual value. So converting them, we can't use net present value here because they got unequal useful life. So you convert them into equivalent uniform annual value. So equivalent uniform annual value of benefit and equivalent uniform annual value of cost. So that we don't have to worry about the fact that they are of unequal life. So based on that, benefit cost ratio for A is 1.05. For B, look at the factor here, everything taken to the future and then converted into annuity in the numerator to get your uniform annual benefit, and then the denominator is uniform annual cost. Ratio for B is 1.355 and ratio for C is 1.359. One word of caution here, the alternative with the highest ratio may not be the preferred alternative. Okay, so we cannot make decisions by looking at the ratio and selecting the best. Individual alternative, if the ratio is less than 1, it drops out from consideration. We do incremental analysis when useful lives are equal. When useful lives are not equal, we do based on equivalent uniform annual benefit annual cost. In that case, benefit cost ratio alone cannot decide. Highest benefit cost ratio, the alternative with highest benefit cost ratio may not be the preferred alternative. I'll bring back more examples in other module. Hopefully you'll find this module useful. Thank you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.